Welcome to Lab Activity 5. This is what we call the Precipitations Lab activity. So today what we're actually looking at is the idea that when ionic compounds, they dissolve in water, they dissociate, meaning they separate because water is polar, and because water has one partially positive side, the hydrogen side, and one partially negative side, the oxygen side. Water can rearrange itself to surround those particular atoms, or ions, pardon me, positively or negatively, and dissociate them. So now those things are floating around in water. That makes what they call an aqueous solution. When we have aqueous solutions and they combine together, so we have ionic aqueous solutions that now combine. Sometimes different kinds of ions can actually swap elements, and they can do what we call a double replacement reaction, forming different kinds of salts, and at that point forming at times what we can see as different precipitates. So let's check it out. This is the Precipitations Lab. All right, so here we go. This is our whole thing with our precipitations reaction. We have to take initial observations, and we have to take initial observations for several different kinds of solutions that are going down. Right now, we have Ki, a clear and colorless solution. We have Na2CO3, a clear and colorless solution. NaOH, a clear and colorless solution. Now we have COCl2, a clear solution, but now we have a pink color to it. AgNO3 is in this bottle because it can get damaged by sunlight, but if we were to look at AgNO3 by itself, we have a clear and colorless solution. Next one, we have CuSO4. CuSO4, we've got right here a clear and blue solution, this turquoise solution. Kind of looks like the solution that we had during our double replacement reaction with CuCl2, because recall that when copper has a positive 2 charge, that it is blue in solution. And lastly, we have PbNO3 too, and we have a clear and colorless solution. For final observations, kids, we have Na3PO4, a clear and colorless solution. All right, people, let's check it out. It's almost like a pastel wonderland right now for our precipitations reactions lab. Right here, we have kind of a darker blue turquoise-ish, or kind of actually now more dark blue, midnight kind of bluish kind of color. We have a turquoise kind of color down here, NaOH and CuSO4. Now let's check a look over here. When we took Na2CO3, we have this kind of very pink, vibrant precipitate up at the top. We have a very turquoise precipitate in the middle. Ooh, that one's really kind of cool, isn't it? Huh? Yeah. Where we had Na2CO3 combined with CuSO4. We took AgNO3 and we combined it with Na2CO3, and we had this very, very, very thick white precipitate. Now, if we take a look at Na3PO4, you can see that we have kind of this almost violet, kind of purple color when combined with COCl2. And we have this kind of baby blue, still kind of a light turquoise, but lighter than, of course, the Na2CO3 combined with the CuSO4. And now Na3PO4 combined with CuSO4, we have this right here. Now, what we want to do is we want to look at this particular chart. We want to think to ourselves, how do these particular solubility rules apply to these particular results given these reactions.